All right, guys, let's take those rules that we just learned in our previous video and use them on some problems. So the question here is like, why do we have to write radicals as exponents? Can't we just leave them radicals? Like, why do we need to have two different ways? And so the reason why we need to have two different ways to write a radical is because sometimes we can't combine things together when they're written in radical form. But if we change them to an exponent, we can combine them together. So here's an example of a problem that we can't do if we just leave it in radical form. Both of my numbers underneath my radicals are 3, but I have two different types of radicals. I have a square root and a fourth root. And we learned earlier this week that you can't combine them if they have a different index. So at this point in time, this problem looks like it's not doable. But if I change both of these into a fractional exponent, then I can do this problem. So I put my index of 2 here so that I don't forget that this is a square root. And I'm going to change these into 3 to the 1/2 and 3 to the 1/4. And now I can use my rules of exponents that we wrote in our secret compartments to finish this problem. This is going to be the very first rule that we wrote down. When I'm multiplying two numbers that have the same base, that means that the 3's are the same. I can combine them together by adding their exponents. So I'm going to add together 1/2 and 1/4. When you're adding fractions, you need a common denominator. So I will need to multiply that first fraction by 2 over 2. And I get 3 to the 3/4. Now, when you're done with the problem, you need to read what the directions say because sometimes they want you to write it in exponential form, which would be this blue answer right here. But sometimes they want you to write it in radical form. So depending on what the directions say, you might need to change the format of your final answer. Also, normally if it starts off as rads, they want the answer to be written as a rad as well. So let's change this back to a radical. This would be the fourth root of 3 to the third. And again, I felt comfortable putting the exponent on the inside because it was smaller than my denominator. So I knew that I would not have 4 of a kind, so it's okay to put it on the inside. Now I do know what 3 to the third is. 3 to the third is 27. So this would be radical form. And again, depending on what the directions ask you for, sometimes they want it in exponential form. Sometimes they want it in radical form. So the blue answer would be correct for exponential and the pink one would be correct for radical. Let's try another one. Okay. This problem, also using our rules for exponents. First thing I'm going to do, I'm going to take care of that negative exponent. We talked about this in the first video as well. So this is on the back of your secret compartments. And a negative exponent means to take your base and make it a fraction, flip it upside down. So instead of 32, I'm going to do 1 over 32. And then once I make it a fraction instead, I've done the act of the negative sign, so the negative sign is no longer there. All right, next I'm going to change this to a radical. For this problem, I'm not going to put the 3 underneath because I don't want to do 32 to the third. That's ginormous. That's huge. Also, I know that 32 is a composite number, so I'm going to factor tree it and see if I can actually take the 5th root of 32. And you can. 32 is actually 5 number 2's. 2 times 2 times 2 times 2 times 2. So the 5th root of 32, that's just the number 2. So in this problem, it was to our benefit to put the exponent on the outside of the radical because, again, I don't want to do 32 to the third. It's going to be a really, really big number. And I knew that I could do a factor tree on 32. So then I was hoping I could take the 5th root. As one last step, we'll need to do 2 to the power of 3, which is 8. And so my final answer for this problem is 1 over 8. So this one started as a fractional exponent, but it was helpful to change it to a radical to get my final answer. Let's try one last problem together. This problem is similar to our first example that we did, where I have a square root and a fourth root, so I cannot combine them together. I don't want to simplify my square root because that's just going to make the problem more complicated, so let's just change these to fractional exponents. So just like our first example, it's 8 to the 1/2 and 8 to the 1/4. This has an index of 2. It's invisible, but it's there. I'm going to add 1/2 and 1/4, and I get 3/4. Now, in this problem, you can put the 3 on the inside or the outside. If you put it on the outside, we can't take the fourth root of 8 because 8 is 2 times 2 times 2, and that'll only give us 3. So I'm actually going to put my 3 on the inside this time so I can get 3 number 8s so that I can get some stuff to get out of that radical. So again, I'm going to factor tree my 8, which is 2 times 2 times 2. And since it's to the third power, I'm going to have 3 of those. Okay, so 3 8s, and they all turn into 2 times 2 times 2. Now that I have this ginormous list of 2s, I can find my 4 of a kind. So I have 4 2s, and I have another set of 4 2s. So 2 2s will get out, and they will become a 4 on the outside. And this one poor guy, he gets left over on the inside. So the final answer for this one is 4, and then the fourth root of 2. On these problems, you really just kind of play with them and see, can I work with it in radical form? If you can't, then change it to exponents. Can I work with it in exponential form? No, I can't. Okay, change it to radicals. Sometimes you change back and forth several times within a problem. And it really is just, you got to keep trying it and see what works. Next week, our first day of live class, we will be practicing a lot more of these problems. And again, you want to have for this section your secret compartments next to you so you can look up your rules for exponents because that's going to be the key to being able to do these problems. This concludes our videos for today.